guys? Welcome to Full Stack. My name is Dana. I think I met each of you at the door, which makes me so happy because sometimes I neglect my duties and leave other people there while I'm emptying my bladder. But tonight I got to greet each of you, and I'm so excited about that. So one of the things that I want to tell you about Full Stack is that we care about community. This is like important to us, so we're so happy that you're here with us. Make some friends, drink some beers, shake some hands, and just get to know some people. We're not ready yet. Mark is ready. Our tech is not ready. So we're going to do YouTube. They're fixing the YouTube things and all that kind of thing. But I want to tell you a little bit about my friend Mark here. He is an expert in ventriloquy. So am I saying that word? I don't even know if that's the right word for it. He says yes. He says yes. Yeah. Mark is
that's the trick.
These
That's the trick.
things. He is like... It's very fantastic. I love it.
I'm from the other room. room.
I love it so much. Mark is going to give us a very thrilling talk on deploying a service with AWS ECS CLI v2.
Two.
You guys, this sounds like the sexiest talk I ever announced. I'm so excited.
I mean, in AWS land, this is thrilling stuff here. The V2
Right?
is what makes it.
We're so excited. Mark works here at Planning Center. Mark, tell us a little bit about your role here. Pause. Welcome to Planning Center's Building 2. This is where we do all of our fun things. Mark and I work here together. My role here is, it's not like I don't know it. It's just always weird for me to describe it, which is so dumb considering the next two words I'm going to share with you. I am the support manager here at Planning Center. And Mark, I don't even know what your title is, if I'm being honest. You're a manager of some kind. I see you in those meetings.
Yeah, platform manager would be my title, which is kind of in charge of overall server infrastructure, kind of operations, kind of application architecture, a lot of that stuff. What we would consider the application platform. We're in charge of that.
I mean, that makes sense. Platform manager, application, platform. I got it. Okay, I'm there. Mark, tell us something interesting about yourself that we should know before we're heading into this fantastic talk, V2.
Something interesting about myself. Well,
You just checked your notes. It's not written there, my friend.
I've been iterating over a demo app called the Hollerizer for I think about 10 years now, and so it's going to make another incarnation, or another version will be debuting tonight. So get excited.
V2. This is what we know tonight, you guys.
Oh no, V2 was like 10 years ago, and I think it was an Android demo. So this is like V300.
Okay, V300 with Mark Rinaldi. Okay, Mark, thank you for speaking tonight. I'm so excited about you investing in what we're doing tonight. You guys, welcome to Full Stack. When we're done with this, you'll see my face again, and I will tell you more awkward facts about Planning Center. But for now, take it away, Mark.
All right, let's go. We'll keep it. We're starting loose. We're keeping it loose. Let's go. So I've been working on I think every time I have to give a talk, I dig through my code bin and go, well, what did I do for this demo? Oh yeah, there's this thing, the Hollerizer. Yeah, just adds holla to the end of whatever you type in. Okay, I have a Crystal version. I saw an Android app version of it. I have a Ruby CLI version of it, and now, in the age of Docker and web, we are debuting a web service version that will, and I have registered the domain hollerizer.com, which because of DNS propagation, I cannot promise will be working by the end of my talk, but by the end of the night, will definitely be working. So, so I'm talking about, we're gonna build a simple service here, and we're gonna deploy it during this talk using the AWS ECS CLI and the new version, the V2. Because right now, currently, V2 is in preview, and V1, if you were to download the official one, is what you'd be looking at. But we're talking about the one that's coming out soon, the preview version. Okay, so show of hands, who is familiar, who knows what Amazon ECS is? All right, cool. How many people are familiar with like Amazon Web Services in general. All right, cool. So what we're going to talk about tonight is basically just a particular part of Amazon Web Services, the ECS, which is the Elastic Container Service, and how this tool allows it to be something that you can easily just push an application to if you come up with an idea. Just breaks down a lot of barriers to deploying production applications. So I just wanted to show that's, in case I didn't actually show it anywhere else, that's what it's called on GitHub. So if you go to it, that's what you're looking for. There's no homebrew package for it yet, so you would just have to click on releases and then download the one that's appropriate for your OS of choice. All right, so I touched on it a little bit already, but why use this CLI? Well, there's lots of services out there that make it easy to deploy applications, right? That you sign up with the service, you add a hook to GitHub, you push master, it deploys, ta-da. Why we're going to use this is because you get a very similar situation to that, experience, I should say, to that, but it's built using the primitives of Amazon Web Services. So say this hobby project ends up turning into more or gets more popular, you're already going to have things set up in an appropriate way for production, and it'll be much easier for you to scale than to try to migrate later on afterwards. So if it can abstract away all that hard work and allow you to do things the right way from the beginning, why not? And that's kind of where this particular tool captured me, because it's just a lot of fun to use. So I'm going to talk a little bit now about some kind of boring high-ed stuff, but we'll breeze through this. But this is basically like when I talk about the infrastructure that it's going to build for you, this is what it's going to give you. And it's going to give you this without you even knowing that you want this or even caring about what this means. So you don't even necessarily have to know, but you're going to know that it's going to give you multiple, what's in AWS land called availability zones, which are different data centers. In case something goes wrong at one, you're going to have another. It's going to give you different DNS subnets. It's going to give you a load balancer, and it's going to put you in either one or multiple regions, depending on how you configure it. And a region is like a geographic area. So we're talking about West Coast, East Coast, Ohio, that kind of stuff. So in this talk, I'm going to be talking about ECS. The Elastic Container Service has a what they call like a traditional setup where you provision your own servers to use with it, but I'm going to be specifically talking about Fargate, and Fargate is just basically means that AWS manages the servers. We don't care. We're saying, take this container and put it somewhere. Hopefully, that works. So, but we don't care. We don't want to own the server. We don't want to have to manage it. We just want that container running. So we're going to use Fargate. Okay. And while I am a huge proponent of just push to master, deploy, get it out there. I learned from the best. I've been chastised enough to be prudent that it should probably have a build and then a test just to make sure it works, and then push to production. So what we're going to do is we're going to also build a continuous delivery pipeline. Just to make sure our service can be deployed from that, and that everything works. And then anytime we push to GitHub, our service will just deploy. So we're going to build that as well. All right. So, all right, let's build some stuff. Enough slides. All right. All right, so we're in a Git project here. Now let me show you the things. ECS preview. All right, so what we have here is the ECS command line app. Obviously dealing with the preview version. it's very 2019, 2020. We got emojis on each of the headings, as is standard. But it has a getting started, develop, release, and settings, right? And since, you know, we're gonna want to deploy, we want to get the Hollerizer out into the world so everyone can see it. We're gonna want to start a project. And because what makes this great is that this is almost all demonstration, and it's almost all over Wi-Fi, and it's almost all using Docker. So the possibility of an explosion is very high in this demo. So we're gonna see if we're gonna get through this. But I did a little bit of it ahead of time just because, you know, I only have 20 minutes, and some of these commands would have taken about 10 minutes to run on initial run, but it's just the initial setup. So the command we're gonna run is ECS preview init. Okay. So it's gonna head and say, you know, like, welcome. It's going to be it's going to explain to us what's going to happen. It's going to walk us through some questions about getting our containerized application or collection of containerized applications onto the internet. We're going to be using the project Hollerizer, which was the one step I set up ahead of time. And then what's interesting about this that differs from any other thing, any other version of this of the AWS CLI, ECS CLI, or you know, many different the similar command line push deploy apps out there. It gives you an infrastructure pattern. So right now it only has one load balanced web app, which luckily is what we need to use. But they're gonna build onto that, and it's gonna be interesting. And you're gonna be able to build custom patterns. So say you have a different pattern. Maybe your web app is a little bit different. Maybe you have requirements that don't fit into their generic. Then you'll be able to customize that yourself, which is pretty neat. But we're going to go ahead and use their load balanced web app. And then what we're going to call this, we're going to call it Hollerizer Web. Oh, and it knows that I'm in Git right now, and it knows that I'm using Docker. It senses the Docker file. And so if you had multiple Docker files, you'd be able to select them here. Otherwise, you can just pick the one you want to use that you have in your app. I only have one, so I'm going to select that. Cool. It's going to go ahead and it's going to create the infrastructure to manage the containers. It's going to set up it's going to set up an ECR repo. It's going to set up a load balancer. So while it's doing that, let's take a look over here, and I'll show you. And there's no magic behind it. It's all running on CloudFormation. So as you can see, we have 3 stacks right here. Like, one simple command is generating all of this CloudFormation. And I write a lot of CloudFormation. And not having to write, you know, 1,000 lines of CloudFormation to get a Docker file deployed is genius. So super excited about that. Okay, so it built those things, and it's going to ask right now. We're going to start with a test environment. When we like to deploy our test environment, yes, we would. Okay, so it's going to go ahead here, and since we're dealing with a little Sinatra app, hopefully this Docker build is going to be super fast. Hopefully it's running. All right. While that's running, I'll take a look at. Sure. Yeah. Oh, okay. Yeah, so I'll take a look at that right now. So. Can you repeat the question for the? Oh, sure. For everyone at home, they're just asking about a little overview of what Sinatra is. And actually, I'm not going to go in depth into what Docker is, because that's kind of out of the scope of this talk. But I will show the Docker file for this, and it's super short. So basically, it just starts with Ruby 2.6. We add the directory. We install bundler. We do a bundle install. We expose 80, and then we run the Sinatra app. And Sinatra is just a Ruby web framework, if you could even call it that, that basically allows you to create clean routes with a single. It's basically helpers around getting a single file Ruby app up and running. That's probably oversimplifying it. It's really old. It's been around a long time. What?
Like Express and Ruby.
There you go. Express and Ruby. Sure. So yeah, we can look at. I mean, this is the extent of my application here. So we've got a health check that basically on get of the root, it returns healthy, 200, and then down below we've got the body of the Hollerizer there. So while that's running, let's see. All right, Wi-Fi is not as quick as my. So we're almost there. It's pushing. Good note for later on the demo. We'll have to do that. So as you can see, yeah. So Sinatra is just that single file app. So it's super small, super quick. Hopefully, it will be up and running here in a little bit. I will take a look at, we don't have an ECS app yet, but we do have, so what this set up was, what happened when I clicked, like, yes, we want to build a test infrastructure, and we want the Hollerizer to be, to use this project. What it did was it generated a CloudFormation template, and CloudFormation is a declarative language for creating like infrastructure basically in Amazon Web Services, and it generated it all for us. It created subnets, it creates IAM roles, it creates load balancers, it creates ECR repos. It's doing all of this just by filling out that, because most people want this. There's kind of like a baseline that everyone wants. And they do a pretty good job of hitting that baseline. So, okay, so it's deploying right now to test. So it pushed. So if we go over here and go to ECS and then go to clusters, boom, we can see we now have a cluster. With that cluster, we are now waiting for. Oh, because I bet we have a CloudFormation template now too. Let's see. Yep, right here. So what this is, when it creates a deployment, is it creates a CloudFormation template. Everything is creating a CloudFormation template. It's all using, there's no magic happening in APIs. All of this is declarative, and you can all see everything that's run right here in your CloudFormation stacks. So we can see. And it even tags things appropriately, which is nice. And we can look at this template. It's a little bit of a beast. Like, I'm glad that I didn't have to write this, because right now for us at Planning Center to deploy stuff to ECS, we kind of have to write this. So pretty neat. All right. Let's see how that is going. All right. Okay. So we have a desired count of 1, a running count of 1. Our app is successfully deployed. And look, there you go. We can access it from this path. All right. So let's go here. In there, it should say healthy, right? Because we're healthy. Let's say. Oh wait. There we go. Okay. Yeah. So we got a service up and running, and using CloudFormation in under 20 minutes, that's a win. But I also said we were going to set up the CI/CD pipeline. So let's go ahead and do that. First things first, we're going to go in here because I noticed, I definitely am slipping because I did not. Oh, I didn't even start. There you go. So now it's a proper version of the Hollerizer. And we will just we will deploy that in just a second. So we're gonna do the ECS preview, and then we're gonna run pipeline this time. Oh. Would you like to add environment to pipeline? Yes, we would. We would like to add test. All right. That is good. Please enter. Oh, I got to enter my GitHub token. All right. So let's go. Let's go. Now let's let's see if we can do this right. All right. All right. So now that created the necessary files that we needed. Now we're going to go in here. We're going to just commit our changes. All right. All right. And then we need to we got to run this command right here, which will fire off our pipeline. So it's going to go ahead and it's going to go through and it's going to create a pipeline that then connects AWS Code Build, which is their tool that will build Docker containers and run tests and do all that. It'll connect that to GitHub, which will then connect to Code Deploy, which will then connect to CloudFormation, which will then deploy our application. So, and we're getting all that just from typing that in. So let's go back here. Let's take a look at this. How many pipelines? Let's see if we, no pipelines yet. No, we created a new pipeline. So, oh, there we go. Okay, so it's in progress right now. So it's pulling right now, then it's going to build on a code build, and it's going to deploy. We're obviously not going to watch it do the whole thing. It's going to take about 8 minutes to run. But you can actually come in here and you can, when you have a deployment progress, you can check out the details. You can tail the log. Right now, it's in the provisioning state. Eventually, you'll see it'll update. It'll run through all of the Docker build. Pretty cool. But let's go ahead and do, oh, wow, look at that. Hit it pretty quick. You can see it's pulling the layers right now. all of this is much faster than over our Wi-Fi, so it's a good move. Let's go ahead and add our production environment right now. So we're going to go ECS preview, and let's see what we got. So we have one environment. We're going to init. We're going to name this one prod. Okay, and so right now, how it differentiates your environment from right now, it wants to set the default. I have in my AWS CLI configuration, I have different users set up. I have a home user, I have a prod user, I have a work user, I have a dev user. So how you would specify where you want the app to deploy to is by what keys you feed into the command line application. So, prod is a different region than development because I have set it. I have prod set to US East 1. My development is in US West 2. So, and those regions are just, mapped to geographic areas, West Coast, East Coast. So, we're going to go ahead and deploy to production. We're going to deploy to our production profile on the East Coast here. Okay. So we're seeing that. So we're going to see our code build succeeded. And back to code pipeline. We should be on. Yep, we're on the deploy step. So right now it's running an AWS CloudFormation update in progress. You can see it right here. I've got one that's running, that's building the production environment. I've got another one running right here, which is running web. So I am going to, you can see right here, it's giving us nice little user readable output of what it's doing, all of which you don't have to, which is really nice. And we've pushed a service, we built a CI/CD pipeline, we have multiple environments, and it's all running on the internet right now. And that's it, we're done. So thank you.
These are such quick clappers. I wasn't
Sure.
ready. I didn't even get the mic on. Just kidding. He's not done. I'm going to run away.
Oh, you can see
Questions. Oh my gosh, you guys. Do you have any questions for Mr. Ronaldo? I'm very excited about all of these pictures that you're making. Is that a throwing up horse? I don't even know what's happening. Cow with udders. Ghostbusters. I think it's inappropriate. Penguin. Also inappropriate.
All right.
I've got a question.
Questions. Geo.
Okay, so at the very beginning, you said that you'd already set up the project. What are the steps? Well, how involved is setting it up?
Okay.
Everything before
I will
you
show
get
you
with the
one thing I did not show, but I meant to show while something was building. It just happened faster than I wanted it to. If you go into the ECS project here, these are the config files that in here that are generated by thing that you can customize. The build spec and the pipeline spec are regarding the CI/CD pipeline, and those are just like in case you need to add like steps to run your tests and stuff like that. That's where you would configure that. In the Hollerizer web app YML, that is where what's specified that config. And so let's look at that real quick. You can see it basically prompted the questions and then set through some smart defaults. So it has the name, what type it is, the architecture, the load balance web app, the Docker file, the port. We're looking at the path for the load balancer rules. We're just routing everything. Gives you how much memory you need, CPU. If you need to set your log levels. And for the environment, if you want to specify your production environment to be a lot beefier than your testing environment, which is always good, right? You want your dev and test to be really small. You probably want to set up auto scaling. You probably want to use that scaling mechanism there, and you probably want to set a higher number of tasks to run for production. That's all configurable in there. So yeah, that's that. Any other questions? Oh, go ahead. Yeah.
So, I'm assuming this is Planning Center, right?
Right.
I'm curious why you would decide to move. Hello.
Sure.
I'm curious why you would choose to move to ECS version 2 when we have EKS now.
Oh, the CLI. That can get into like, I don't know. It's like talking politics, right? You start talking ECS versus EKS. This is just like the easiest way to get a container. I'm not even talking production workloads. I'm talking you saw a really cool talk at Full Stack and you're writing a neat little Elixir app that you want to get on the internet. And you have an Amazon account, you have a AWS account, it's already gotten a credit card in there, you're already ready to go. The easiest way to do that would be to do this for me. If you wanted to mess around with the primitives about how things are hosted, if you're interested in that, that's why I would present this. Now you can do EKS as a cargo ship, and you can do tremendous talks on running very large production applications on EKS, but not what we're necessarily dealing with right here. This is mostly just Fargate, quick, using AWS's tools. So I say try it. It's a lot of fun.
More questions from fantastic folks? Okay. Mark, thank you so much for giving this talk to us. I do, wait, before you leave though, I'm going to do my very best to embarrass you. Or am I allowed? Thanks. Cool.
Sure.
Thank you. So one of the things that I love about Full Stack, honestly, is it gives people an opportunity to invest in something that they care about that maybe they're not able to build into their normal everyday workspace. And so, I mean, you're talking about AWS. This is not stuff that you get to do on the daily, right?
No.
Okay, so you're doing this. I'm going to call this a passion project. May I have your permission? Cool.
Sure.
So as a speaker, talking about a passion project, what would you say is the benefit for you as the speaker in giving this talk at Full Stack?
What was the benefit of giving this talk? Well, I think that there's a lot of things in there that I think are really neat, and I think people could be interested in. It's just kind of overwhelming, and especially with Amazon Web Services, there's a lot of things. If you click down on this, the services tab here, I mean, you've got there's a few things in there, and it's a bit overwhelming. So anytime there's a tool that they create that is open source, that that kind of ties things together in a way that is easy, but yet shows you the complicated things that are going on underneath, I think is really neat and worth supporting, so that they do more of that stuff. So that is why that particular project piqued my interest and why I'm talking about it here.
I love that. One of the other things that I love about Full Stack is just that it gives us a chance to build community. So very short community builder session right now. We're going to take about a 10-minute break. I'm done embarrassing you.
All right,
Thank you for allowing me to use you as a guinea pig. We're going to take about a 10-minute break. We're going to come back about 8:10. There are drinks in the see-through fridge in the kitchen. There are some snacks in the see-through containers in there, and there are restrooms behind here. There's a cute little restroom sign lit up back there. So help yourself to whatever, and we'll see you in about 10 minutes. second. And by a hot second, I mean right this one. Um, If you haven't gotten a drink or gotten a snack, grab that. Come on in. We're going to listen to Richard talk about something I don't know because I don't have any cheat notes that I can read off of his screen. But Richard is a seasoned full stack talker, and I'm super excited for him to be sharing tonight. Richard, what are you speaking on tonight?
This is a self-help conversation.
Self-help.
Self-care? No, I'm joking.
Self-help, self-care. This is right in my wheelhouse.
A gentle introduction to TypeScript.
And you've lost me. Awesome. Gentle. Okay. I'm very excited. Okay, Richard, can I ask you, what are the things, like, if you were going to start this conversation, pretend you're going to give me the elevator pitch about a TypeScript talk, me being somebody who has no idea what the hell you're talking about.
Yeah.
What would you say is a TypeScript talk about?
This is a programming language. It's kind of an extension of JavaScript, and you should use it.
And you're going to tell me why.
And
Are you here to convince me?
I'm not going to tell you why. I want to show you why.
Show me why.
Show you why. yes.
Okay, all right, I'm here. I'm here for this. Okay, Richard, thank you so much. You guys, please welcome Richard to this talking stage.
All right. Can you guys hear me? I'm afraid, I can't hear myself, so do I talk louder? Louder? Is this too loud? Sorry. Hey, thank you for having me tonight. We're going to talk about TypeScript. I kind of want to gauge the audience. How many people are using TypeScript right now? Woo! How many people are thinking about using TypeScript? Woo! How many people are on the fence about TypeScript? Woo! How many people don't care about TypeScript? Woo! All right, that's good. Good to know. So, one person in production? In production? Perfect. You're not using it, Mike, not since you left us. So I am here to give you a gentle introduction to TypeScript, and the reason why I say a gentle introduction to TypeScript is TypeScript's actually can be pretty complex. You can actually get into some weeds with TypeScript, and what I want to give you is the point of view of using TypeScript from an application developer that's using it day to day, like writing a service, and not a library developer, someone who's developing a library in TypeScript. And that's a fundamental difference when you talk about the skill levels needed to use TypeScript. And the reason why is library developers actually have to really know the language really well if they're going to get into some of the more hairy aspects of TypeScript, like generics and stuff like that. So what I want to do is give you a broad brush so I don't scare you away from TypeScript, to kind of give you enough knowledge or to give you a sense of the kind of knowledge you would need to be productive in the language. And that's it. I'm not going to try to spend too long convincing you why it's cool or any of that, because I think you'll find that it's actually kind of neat. All right? So that's my spiel. Who am I? I am Richard Clayton. I'm a principal software engineer at PeachJar. I'm a 3/4 stack developer, otherwise known as a pear-shaped developer. I don't touch HTML or CSS. Don't ask me to do it. As you can see from my ugly slides, that's about as good at design as I am, and I literally stole this from someone. Just other little things about me. I'm a former Marine Corps meteorologist. I'm a Virgo, just in case you care. I'm a foodie. And the last piece is actually particularly important to this talk. I am a reluctant TypeScript zealot. And the reason why I say this is, when I started at PeachJar, we did not have, we really didn't have much of a code base in TypeScript. And our architect, who had started a couple months before me, was like, the whole company is going to TypeScript. 0 developers, except for the architect, actually use TypeScript. And I was like, nah, man, I've done Node for years. I don't need it. TypeScript is just it's going to be a nuisance. And so that's where the reluctance came from. And I found out that I was a zealot about TypeScript about a year ago when I went to start a hobbyist project on my own. I'm like, I'm just going to write something, right? And I started a Node, and I absolutely hated JavaScript, abhorred JavaScript. And I literally was like, I'm going to take the time to introduce TypeScript into this project. And that's how I knew I was won over by TypeScript. So I'm just bringing this up that in the sense that, I know some of you guys are on the fence, but I'm going to tell you that after using it, I think you'll really develop a really strong affinity towards the language. Okay, so specifically at Peachjar, to kind of give you a sense of like, how much we're using it, we started from like 0 repos, and now we are 4 React apps using TypeScript. We're 30 microservices, 3 internal service frameworks already in TypeScript. All of our CI pipelines are now in TypeScript thanks to GitHub Actions. So like we have really gone full bore on TypeScript. And just to prove that, I wanted to show you our like GitHub history with 51 repos, primarily TypeScript. That should give you a sense of how much we've adopted it. So, and I put this up here because Mike Bobadilla, who's a former Peachjar, made me feel really insecure about my TS knowledge. Thanks, Mike. Okay, so the roadmap is I'm gonna start gently, and we're gonna talk about kind of basic TypeScript, and then we'll get a little bit more advanced, and at the end we'll talk a little bit about kind of the myths of TypeScript, some of the advantages of using it, and then also the disadvantages of using it, because I want to be an honest broker here. Okay, so how is TypeScript used? So a lot of people, like when you think of like a new language, you think like the barrier of entry is going to be like huge, right? And I'm here to tell you TypeScript is probably, like if you have a Node environment already created, TypeScript is so easy to use. It's literally these commands right here. It's just install the library, either globally or locally, depending on what your preference is. I recommend locally. And then create a TypeScript file. Hey, by the way, most TypeScript is just JavaScript, so this is interoperable between languages. You compile the file using the tsc command, that's TypeScript compiler. And then if you list your directory, what you'll find out is that you have a JavaScript file, you have a TypeScript file and now a JavaScript file, because TypeScript is just JavaScript. And I'm going to emphasize this multiple times. TypeScript is just JavaScript. Now, once you have a compiled TypeScript file, which is just JavaScript, you can run it with Node. And there you go. You have literally just done TypeScript. It's that simple. And then there are also some intermediate tools that you can use to avoid the compilation step. There's a framework called tsnode where you can use that and you can replace Node and not actually run the compilation step. You'll use tsnode to run your TypeScript files directly. But I will say that in all of our repos, we don't really do this because tsnode is kind of slow because it's got the compilation step, but also most of the time we are compiling and we're checking the compilation step. We're optimizing our code before we actually run it in production. So tsnode is rarely used in my opinion. Okay. So let's talk about some, yep.
When you do that, so I haven't done on the Node side yet, when you debug,
Uh-huh.
will you have debuggers that will actually use the TypeScript code for the debugging, or are you debugging with JS?
So that's a great question, and
Repeat the question for our viewers.
I
online?
absolutely
Thank
can.
you.
When we're debugging the code, am I debugging the TypeScript or am I debugging the JavaScript? Is that what you're asking? So I don't know if tsnode even has a debug mode because I run Node primarily. But here's the thing. The TypeScript compiler is incredibly advanced, and one of the features that it adds is the source maps, right? And so I actually do debug using Node, and I use the Chrome Live Debugger, and that loads the source maps, which gives me, I actually do breakpoints in TypeScript, not breakpoints in JavaScript. And I can show you how to do that later if anybody's interested. But yeah, most of the time, what's really beautiful about TypeScript is you never actually interact with the JavaScript, the compiled JavaScript directly. The source mapping and the tool chain actually lets you use the TypeScript source maps and stuff. And so you have a very clear idea of what's going on. So, okay. All right, so let's do some basic TypeScript. Okay, so JavaScript is an amazing language with only 3 primitives. It has strings, numbers, and booleans, right? And the way that TypeScript allows you to explicitly define the type of something is to use a colon and then the type after the variable name. So, by the way, that same architect convinced me not to use semicolons. That's why you're not going to see any semicolons here. So if that seems funky, I'm sorry. But an important thing here, though, to mention is that here you see foo assigned to bar, and then you see const foo with the type string equals bar. TypeScript is going to implicitly give foo the type string. So a lot of times you don't have to explicitly declare your types. But once you've like assign that type, TypeScript's going to consider that type, that implicit type, every time you use it from, from that point on. So if you say, hey, I'm going to assign something to a Boolean value true, this is reassignable is now forever a Boolean. You cannot assign it to a string because its implicit type is Boolean. So that's an important characteristic here. So we saw strings, numbers, and Booleans. The next thing is arrays. So I'm going to talk about specifically something called an homogeneous array, which means that all the values are the same type. And this is kind of the default when you're working with TypeScript. So when you say, hey, I have an array, and my array is sodas, you can see that every element in this soda array is a string. Therefore, it is a string array. And this is the syntax for an array of strings. Is this too small? I can... This is what you get when you steal code from someone. So, of course I can't do that. Sorry. And I'm done. Okay. Yeah, apparently I cannot resize this for you, and I apologize. So TypeScript is going to give a homogeneous type to every element in the array. And so if you want to change the type, so here we have a complex example with 1 and hello and true, right? What's going to happen is TypeScript's going to say, in this array, the types can be number, string, and Boolean, not anything you want to. So what TypeScript tries to do is it tries to narrow your type signature to the most restrictive type that you possibly, that you can based on the examples you've given it, unless you've explicitly told it what it can be. This little pipe operator, by the way, is called the union operator. So it means that the type, and it's just like GraphQL unions. It basically means that the type can be any one of these things. Tuples. So TypeScript formalizes the notion or the idea of a tuple. Most other languages actually have real tuple types, but for JavaScript, I call this a heterogeneous array, meaning that you're explicitly going to say that there are this many elements and these are the specific types in that element. So imagine we had a latitude and longitude tuple, so it's always going to only be a 2-element array, and it will be of number. And you see that you define the tuple by actually putting the types inside the array. Pretty simple. And your tuples can be as long as you want. They could be 100-element tuples. I don't know why you do that, but you can. Okay, objects. So objects, super common in JavaScript, right? Objects are defined like you would see an object, right? Here you see I've got my type signature, and my type signature is this ugly map of key name to type, right? Now, this is ugly. You would probably never do this in TypeScript, right? Because who wants to have a 200 character line string because you're just specifying types to an object? So the next thing to talk about is type aliases. So this is when TypeScript becomes really powerful. So here we have this object, and we kind of know its type signature, and we probably want to reuse this type signature every time an object of that similar type is going to be used. So for those types of things, you can create an alias, and this is like a name to refer to a known set of types. So here I have a bucket item, which could be a number. This is not correct. This should be a string with no quotes, or a Boolean. And then I can define an array of bucket items, right? Just like this. And so now I can say that this bucket is of type, or this variable bucket is of type bucket. And so now we know that it's an array of either number, string, or Boolean. And the same thing with latitude and longitude. I can say, hey, a lat long is a 2-number tuple, and that's what it looks like. Objects, same way. And what's really great about TypeScript is the type definitions really match kind of the shape of the types that you're defining. Okay? So, one thing that I would say is a pro tip that you should really consider is that you can also type alias primitive types in TypeScript. And one of the reasons why I recommend this is it leads to code clarity. So you remember in the last example, we talked about a timeout being a number, but what does that mean? Is that a timeout in seconds? Is that a timeout in milliseconds? What does that value actually mean? And so you can use these type aliases of primitives to really speak to what the actual type is. So I can say, hey, an int is a number, right? Now this doesn't enforce the fact that this number is an int. This is just you coaching the other developers or yourself that you're expecting an int in this scenario. And I can say that I have milliseconds, which is another type that is also type int, which just happens to be a number. And then when I define my options type, my object that has all these options, I can say my timeout is milliseconds. And so when people are reading code, they're like, well, what is that timeout? Is that seconds, milliseconds, nanoseconds, picoseconds, right? You know implicitly what the type is asking for. And so that to me is the fundamental power of TypeScript, by the way. Okay? Another cool thing is that you can actually use constant values as type definitions. So for instance, let's say that I was going to model a wind measurement. I can say that, hey, I have knots, that's nautical miles per hour, which is an integer. I have a direction, which is a string that can only be these values. And you see how we're using the union operator again? We're saying it can be north, northeast, east, southeast, whatever. And I have a sustained speed, which is knots, and a gust speed, which is knots. And then I have a tuple that represents a wind measurement. And so here, what we're doing is we're basically providing some pretty good type hints over what is expected in this tuple. And what's really cool is when you compile this, if you use a value other than north, northeast, south, if you don't use one of these known values, you'll get a compilation error. And that's only if you're doing the literals. By the way, like TypeScript's going to do no runtime checking because there is no such thing as TypeScript at runtime. That's an important thing to remember. Okay? And here I actually show that specific example, which is if I want to know what directions are capable and I do like a console log direction, and direction before was defined as a type, direction doesn't exist at runtime. It was just this type artifact that basically got baked away when the code was compiled. And so that's one of the kind of gotchas with TypeScript, is that your types aren't real. They're only there to coach compilation, and beyond that, they don't exist. And the same thing's true if you're like, hey, what's the type of gust? I expect it to be of type gust speed, but it's not. It's really just a number. Okay. Now, we saw the union of literal values with a string, but that's just an enumeration. And actually what's really great about TypeScript is it does have a formal declaration called enum. And the cool thing about enum is enums in TypeScript are just JavaScript objects with known fields and values. And so instead of doing like a union of restricted types, what you can do is you can define an enumeration, and then because it's just an object in JavaScript, you can do cool things like you can in other languages with enums, where you can say, give me all the keys of the enum, give me all the values. And I use this a lot when I'm using Joy, which is a validation framework in Node. I can create an enumeration and say, whenever I'm validating a request, this property specifically needs to be one of the values of this enum. And I can just do it by saying, hey, anything that's a value of the enum. So just kind of a cool little trick. Okay, let's talk about null. Null is also a type in TypeScript. And it's used specifically like if I wanted to set a variable to null and then later define it, like say we have some kind of conditional logic and I need to like conditionally set this variable, you're probably going to initialize it to null. But if you initialize something to null and then you set it to like another type, like a string bar, that's a compilation error. And so what TypeScript really tries to do is it tries to make you think about your use of nulls and your use of undefines, because that's most often the common mistake that people make in their code is that they're using nulls and undefines and not doing type checking to see if those values exist. And so what TypeScript's going to do is it's going to make you explicitly define a union that says this can either be a string or null. So we haven't learned anything new here. We're just saying that null is a type and that you actually have to deal with that like any other type in the system. Undefined is the same way. So for instance, like if you have an optional key, in an object, you would say, hey, it could be a string or it can be undefined. And as I said, if you have a good editor with the language, there's a language server that will help you. What's really great is it will help you write better code around TypeScript, because when you have a variable that could either be like null or undefined, and you start to use it, that editor or that language server, like VS Code or like JetBrains IDEA, will actually tell you, hey, when you use this variable, you need to check to see if it actually exists. And so what's really cool is you'll have cases where you'll get like the little squiggly angry lines at you that says you didn't do like an existence check on this variable. And that's because TypeScript has forced you to define something as null or undefined. Now, if you know better, if you're like, hey, at this point I know the value's set, you can actually override that behavior by using the I know better operator, which is the exclamation point, which basically means, that's not the actual name of it. I don't actually know what the name of the exclamation point is, but it's actually basically saying that in this instance, I'm telling you, compiler, that this is not null, and to ignore your null check, to ignore literally like an if, this, that, whatever operation. And here this is an example of using the ternary to access that possibly undefined foo variable. This doesn't cause a compilation error because you're literally like, you're checking for the existence of foo. But like here, if you know better, you have to use the exclamation point. Does everybody get that? Okay. Which leads to something called, that I actually do know the name of, the optional chain operator. And this is the question mark. So if you have like an object that can have like deep linking of like possible undefined or null types. So here I'm kind of modeling like a linked list. And if you can go down that linked list and there's possibilities that like some of the elements could be like null or whatever, and you want to do like a deep access into those properties, the question mark is just like the coffee, if you're used to CoffeeScript, it's just like the CoffeeScript operator, where it basically says, if this is null or undefined, just don't throw a null or undefined, just return null immediately operator. So this is kind of like a nice language feature just in case you have deeply nested types. And finally, any. Don't use any. So any is like, every type is any. It's like your root type. And the reason why I say don't use any is that I've encountered code bases where people will have like this really complex object and they'll type the parameter any. And what you're basically doing when you use any is you're saying, I don't care about this type, right? I'm not going to tell you what it is, TypeScript. I'm just going to leave it to guessing. And basically, you're back to JavaScript when you use any. So that's my first kind of like important language thing, is avoid any if you can. But any is useful, though, in certain circumstances. Okay, so we've seen the primitives. And now let's talk about functions, and let's talk about like classes and stuff like that. So functions. Function is just defined just like a JavaScript function, except you have type parameters with it. So, here's classic kind of JavaScript function where we're basically providing or supplying the type to the parameter, and then you use the colon after the parens to represent the return value. And that's true also for the arrow functions as well. Gosh, sorry. All right. You can also, by the way, pass functions. So, if you were like passing a function, your type signature for the function would actually be defined recursively in the function. So, my recommendation is use type aliases. Since we're talking about functions, there's an important type to talk about, which is the void type. Void means that you're not returning anything, and TypeScript basically makes you explicitly say that. If you don't return anything, TypeScript will implicitly call it void. But if you have mixed types, TypeScript's going to guess at what type you're returning. So if you want to explicitly say that you're returning nothing, I recommend using void. It just basically means nothing's coming back. And this is one of the cases where any might be helpful. if you like don't care about the type that's returning because you want to like short circuit a function and you want to use return, fine, use any. But just remember that you're letting all the developers that are going to use your code base in the future know that like this is kind of an ambiguous function for them. And then there's also never, which I've never actually used, but never is a type to indicate that this function will never return, right? And the only time a function can never return is if you throw an exception. So the only case that I can actually see that being useful is if you're not implementing the function and you want to throw an error just in case someone actually tries to use it. But it is a valid type in TypeScript. And then because we're in JavaScript and we don't have rigid type signatures, we also can support variadic functions. And so the way that you support a variadic function in TypeScript is you use the splat or the ... operator. And this basically means that I'm going to accept a greeting and then any number of strings after that separated by commas. And what that TypeScript's going to do is it's going to turn it into an array for you, which is actually really nice. So you're not going to have to guess at the arity of the function and do some kind of metaprogramming to figure that out. All right? So that's basic TypeScript. Does anybody have any questions about basic TypeScript? I promise you there's not a whole lot left here. Okay. So let's talk about classes. So you can use OOP in TypeScript. In fact, TypeScript enhances OOP in many ways. So you can define a class very much like you can define a class in JavaScript. But the function signatures stay relatively the same as you saw with the functions. Like if you have a method and like constructor, you would add your type params and then your return type if it's not the constructor. And then inheritance works the same way. You can extend things and call super. But where TypeScript gets really cool with OOP is that it actually adds formal visibility fields. So you have public protected, private visibility attributes. And actually TypeScript will compile things in such a way that it tries to actually enforce that for you. Whereas JavaScript, there kind of really is no way to do that unless you establish closures and you do funky stuff. So what's really cool about TypeScript too is like for certain methods, particularly the constructor, it can do things where it like basically, like if we had this example here where we defined our types and then we set them explicitly, Java style, TypeScript will do that for you if you just declare the visibility in the constructor. So this is literally doing the setters. You have a public field called yo and a public field called mama set on the object, done for you. I think Ruby does that too, right? Maybe? I'm not a Ruby guy. I'm looking at the Ruby guys and they're not telling me. Anyway. And then you can have protected and private methods as well. Okay, now, all of that to get to my favorite feature of TypeScript, which is interfaces. So JavaScript has no notion of this at all, right? And this is actually probably one of the reasons why I was so hung up on coming back to JavaScript, which is the fact that there's no way to actually write code in abstract in JavaScript, right? Like, you can't define some like alias type and then create kind of a contract and then write some nice clean domain code, right? Like JavaScript doesn't really support that. I mean, you have duck typing and stuff like that, but there's no real way to formally declare your API or your code base. And that's something that TypeScript introduces with interfaces and then types. So an interface is just like a Java interface, if you're familiar, or a C# interface. Except that it adds fields as an interface type, which might have happened in later Java, I don't know. But this is kind of like unique to me in that TypeScript added this. So you could literally say, I'm expecting this thing, this notifier that has my field as a property of like this object, and then also has a method called notified that accepts this type signature for the function. And that's beautiful because now I can write like code that uses notifier, but never actually have a physical implementation of notifier. And so that's kind of like one of the really beautiful things about TypeScript is that you are actually writing an abstract domain model before you actually get into doing the implementation. And this shows you basically you implement notifier or you implement the interface like you would like Java or C#. And then another really cool thing that TypeScript added was functions are first-class citizens in JavaScript. So interfaces should also be able to model functions. And so you can use, this is literally the function interface notify, which means that I'm expecting a function that has this type signature. And it's not an object, it's just well, I mean, I guess functions are objects in JavaScript, but more importantly, we're modeling formally something that is purely a function and not an object with a method. And then here's just me showing you, how it can be used. By the way, another great thing about TypeScript to mention is that TypeScript kind of supports duck typing, which means that you don't have to formally declare like that your notify interface implements user ID message. Technically, with this interface, console.log is a formal implementation of the interface. And you don't have to do anything special to tell TypeScript that, which is kind of neat. Oh, getting ahead of myself. Here we go. So once again, I have a function that takes a notify interface, and here I go. Like I said, console.log is an implementation of that. So it's just another thing that TypeScript makes really easy for you. All right, now a common question when people start to adopt TypeScript is what is the difference between types and interfaces? And to be perfectly honest, from a practical implementation standpoint, there really isn't too much of a difference. There are syntactic differences, like interfaces can be extended, interfaces can be explicitly implemented, but in reality, like it all gets boiled away when it gets compiled to JavaScript. And you can actually get away with types where you would normally interfaces and vice versa. So I wouldn't get too hung up on, should I be using a type or should I be using an interface? All right, advanced TypeScript, not today. The reason why I added this slide is I just wanted to give you kind of a heads up of where you might go from here. And this is where I was saying, like, this is where you start to get into some of the more kind of library writer-esque type things that you might need to know. There are, obviously symbols in JavaScript, but symbols are also a formal thing in TypeScript. There's advanced generics. We haven't really gone into generics at all, but generics are a way to generically implement behavior across any known set of types. There are modules, there are namespaces, there are decorators, which are like Java attributes. So there's a whole set of language features that aren't commonly used in TypeScript, but are available to you if you are writing some pretty advanced TypeScript code. So finally, this is closing. I don't know how I'm doing on time. Doing good? Okay. Why TypeScript? So I've shown you kind of a broad brush of TypeScript, and I want to talk about some of the myths around TypeScript. And this is like, a lot of times, this is what like your boss is telling you why he doesn't want to use TypeScript. The first thing is that types will increase the complexity of your code. And it's true, you're going to add more lines of code, you're going to add more stuff, but I would argue that you really have a ton of hidden complexity already. You just don't know about it because you haven't formally declared your types. You haven't formally declared your model. You're just like throwing JavaScript code around and hoping for the best, right? Types will force you to use OOP. As you saw, there are formal definitions formal ways for declaring functions as either interfaces or alias types. So you can be completely functional and never actually use a class in your TypeScript code base. I won't be able to use pure JavaScript libraries, right? So I didn't make this stuff up. People actually have said this before. So you can absolutely pull in any JavaScript library you want to use. The problem though, and this is one of the hairy parts of TypeScript, is there is no type signatures. So when you pull stuff in, you're basically going to either have to declare the type signatures yourself, or you're going to have to declare it as any, right? And you're going to have to start using it untyped. This is a common one. Oh my gosh, not another CoffeeScript or Flow or whatever your compiled to JavaScript flavor of the week. And that is true, right? Like this is another language built on TypeScript or built on JavaScript. But I would argue that at this point, TypeScript has had far more traction across the community than any of the other compiled to JavaScript languages. And then my TypeScript won't be able to use, my TypeScript code will be unusable in pure JavaScript. We know that's not true because it compiles to JavaScript, and JavaScript is, is the root, language and can import that TypeScript code and execute it just like any other library. TypeScript's going to dramatically slow down my development. Well, I would say that I think it's actually the opposite. When you're guessing at the type signatures of things, when you're looking at other people's code and you're like not understanding the shape of a variable, I would argue that that really is a drag on your ability to code, and you don't know it yet. If you aren't using types, you really don't know that yet. It won't be until you get some monstrosity of an object passed into a function that was created by Bob, who's left the company, and now you're trying to like pick through like logs to figure out what that signature is, that you start to really grasp the importance of having defined those interfaces better. And then unit tests. The myths go both ways. You don't need unit tests anymore because you have TypeScript, and then I don't need TypeScript because I have unit tests. And I'm here to tell you that like I have TypeScript code that's been buggy because of types that I wasn't anticipating, and I've had, JavaScript code with plenty of test cases that miss very basic type inference errors. And so I honestly believe this is not a silver bullet. You still need tests. And then the benefits of TypeScript, going through this really quickly: better clarity, your ability to model abstract concepts, an intuitive type system that feels like JavaScript. It's not like some thing that feels like it's bolt-on. You have all the futuristic JavaScript features right now because the TypeScript compiler is just like Babel. It's going to compile any of the new ESNext features like import and the generator functions and all that stuff, and it will compile it down to whatever target you want, like ECMA 5. It has a fantastic ecosystem. I mean, I would say that all the popular libraries in Node and probably on the web side already have TypeScript definitions, and all the new libraries are being written in TypeScript. Has awesome IDE support. Way better IDE support, by the way, than JavaScript. In fact, a lot of the cool IntelliSense features that you're getting in VS Code right now for your favorite libraries are because they have TypeScript definitions. And VS Code is actually behind the scenes pulling those TypeScript definitions and giving you syntactic hints. And a reduction in the need of your JavaScript docs. I don't write docs anymore. If your code is clear enough, you can actually, and you're using types, you really don't need to do like the inline documentation. It doesn't mean you don't have API docs. It just means that there's a lot less of a need to coach people into what your code is actually doing. Finally, what are the disadvantages of TypeScript? TypeScript is just JavaScript, and it gets baked down into JavaScript, which means that you have no runtime introspective of your type system. And this got me as a library writer, because I wanted to know if something was an implementation of one of my TypeScript interfaces. That type system doesn't exist anymore. So you can't ask questions that you might in another language like Java or .NET that actually keep that runtime like type information. It's just not there. Complex types with generics can be confusing. You can get into some really crazy places with generics, and that's not unique to TypeScript. I mean, Java and C# and other languages have the same problem, but it is still present. And if you start writing libraries as a library author, you're going to have to deal with these complexities. And then finally, and this is like the worst part of TypeScript, is having to deal with JavaScript libraries that don't have type definitions. I once had to type the DocuSign API, and it was, I had a TypeScript declaration that was, I swear to you, it was 5,000 lines because it was so gnarly. And sometimes you have to do that because you're interacting with an API really directly, and what you want to do is you don't want to have a lot of like any's. You don't want to have like a lot of deep access to properties with no type declaration. And it also like makes your job easier when you're interacting with the API that you actually have created a type definition, because then you have that, like I said, with a really complex API, you have that type like IntelliSense support where you can be like, all right, this object has this property, and then I can nest down into this property, and it just makes your life easier. Conclusion. Hopefully I demonstrated the basic and intermediate usage of TypeScript and gave you kind of a sense of what it would be like if you were writing in TypeScript. And I discussed the strengths and weaknesses of TypeScript. And that's it. Does anybody have any questions? You guys are super quiet. I mean, come on. You guys want to, what are we like on time? Couple of minutes? You want to see some TypeScript actually get written? Yes? Yes? Okay. Sorry. Yeah. Uh-huh.
As I look at that, really your drawbacks are, as you were mentioning drawbacks of TypeScript, I mean, really what I infer from that is it's more of you're really pointing out the pains that once you get used to TypeScript, doing other things are really pulling you back to JavaScript. All those problems exist in JavaScript today. It's just that you get spoiled by having the types and being able to infer interfaces and things like that. So when you deal with other things, it's painful.
I completely agree.
Is that fair?
Are you going to make me repeat that? Okay. Yeah, I 100% agree. The problem with TypeScript, like you mentioned, the weaknesses of TypeScript are JavaScript. They really are. And this is a gentle introduction. I don't want to browbeat you. Like I said, I'm a reluctant zealot. Here's what I do. I would encourage you to start using it. And you're going to be annoyed with it in the first 2 to 3 months when you use it, because you're going to like, oh my gosh, I'm so much faster in JavaScript. But you're gonna come up over like a crest in your what is that, the hype cycle, right? Before you hit the trough of disillusionment, you're gonna hit that crest where you're like, this is awesome. There really isn't a trough of disillusionment, by the way. But yeah, you're gonna hit a point where you're like, yeah, like having a type system to fall back on actually is extremely productive. And yes, I spent a lot of time typing my code and creating this abstract model, but it turns out that now with like a sensible IDE, like IDEA, not VS Code, a sensible IDE, you're gonna really flow through, and you're gonna be able to really leverage those types to really understand what your model looks like. And with that said, I'm just gonna prove it to you by actually writing some TypeScript. So that's cool. Do I have enough time?
Yeah, go for it.
You just ignore me. You can leave if you're tired of TypeScript. Okay. So let me close this up. Okay. So let's call the Hala API. All right. So I'm just going to create a little directory here called Hala or Ola. And I am going to, let's init. Yeah, sure. Oh, you're so needy. Dark mode. Is this better? I'm not going to do a whole lot in the terminal anyway. Anyway, so I just initted a project here, and I'm going to install and save TypeScript. TypeScripty. And let's throw in something cool like jest as well. I don't know why I keep doing this. I keep thinking of the modules I need, and then instead of doing it all at once, one at a time. Wow, is jest really that big? This is that black hole of NPM dependencies, and just all right. And last, I'm going to install Axios. Oh, so one thing, by the way, just to mention, so not every library ships its own types, right? I believe these three, TypeScript definitely ships its own types, but in the case that you encounter a library that doesn't have a type signature, and you know that because when you go to the GitHub repo, there will be a file called index.d.ts, which is it's the type definition signature for that library. If you don't have it, chances are the definitely typed library or the definitely typed organization has an NPM package. And you'll do that by adding the @types / the library you want types for. So if Axios didn't have types, I can install the types by referencing that. So I'm going to add a file real fast, index.ts, and then I'm going to open up a real editor. I know you guys are joking. Listen, it's got to boil the ocean. I could feel my laptop getting hot already. Okay. I have to do this because honestly, the IDE really makes this worth it. Just to throw that out there. All right. Oh yeah, I have a joke. How do you know when a joke becomes a dad joke? You don't know? This is the ultimate judge. When it becomes apparent. Sorry. That's the ultimate dad joke. All right. Okay, so I got my index.ts file. Okay, so awesome. So let's just start writing some code. All right, so I'm going to use Axios to call our Hala API, right? So what I'm going to do is, we're going to use Axios, which is promise-based, right? So I need an async function to execute this in. So I'm just going to async function main. And if I want to be really pedantic about this, I could say that it's going to return a promise of type void. And this is the use of generics. And you notice how it's yelling at me? It's like, yo, like you didn't actually like return something yet. And then I'm just going to run it. All right, so let's import Axios. Actually, I think you just go, sorry. Axios from Axios. And then I'm going to go, all right, let's go ahead and let's go axios.get. And then I have, here's my URL, right? And I'm going to await it. Data equals await. And then I'm going to console.log data. Okay, we're good, right? I really don't know why it's yelling at me because we have returned void. Anyway, so let's compile it. So tsc index.ts. What's that? Oh! Oh my God, is it? Okay. It's because I'm not using the ESNext in the compiler. So what I'm going to do is I'm going to cheat. And I'm going to go to my development repo, to a known repo, and pull a TypeScript config. So you didn't see this, okay? You don't know the directory structure of my apps. Stop it. Why am I not seeing it? Oh, copy, that's right. Oh, shit, sorry. It helps if I have the directories right. Then I want my TS config. Oh, I'll bring in, yeah. Let's bring in TSLint as well. It's kind of cool. Does that mean I'm done? You're like, you're done, go away. Okay, so cool. All right, so now I've brought in my TS config, and ideas should rework itself and stop hating me. There we go, hey. And this is literally because what we're doing is we're telling TypeScript that we're going to use ES 2017 with the async iterable extensions, and we're going to compile it down to ES6. So TypeScript was by default assuming that we're going to be in ES6 land. So that's it. All right, so let's compile it. tsc index.ts. Oh, sorry. Do I really have to do this? Can you not be smart enough to just load it? tsconfig.js. Oh my gosh. I swear to you, I actually do TypeScript. It's not just a joke. What is the config? What's that? Is it a JSON? It is a JSON. But it was, I thought it was yelling at me that my that it didn't know what config was as a property. Yeah, see, it's saying like, doesn't know the config. Declaration. Build P. Oh, compile the project path using the configuration file. P. Who uses P as a, oh my gosh. So the parameters are not intuitive. Oh my gosh. Okay. All right. So when in doubt, cheat again. We're going to copy my package.json in. Package.json. Haha. That'll be npm run build. How do you like that? It's not in my root directory. All right. Let me make a dir source and move my index.ts into source. Place. Look, it worked, guys. In this case, my config goes to dist. And, oh, by the way, the map file, you can see we have source maps for the JavaScript. And then if we, oh, that's it. So there we go. We just called the Hala API. Doesn't render as cleanly in the command line. But yeah, I mean, like, so just before I go, before Jeff or Gio kicks me off, let me just show you something real fast. The stuff that I added in was not that big of a deal. Like, there wasn't a whole lot here. And actually, I think what was happening was that when I did the build, I wasn't actually using the local node modules version of TypeScript. I was using the global, and the global was like not finding the config in its whatever path it's looking for. But if what I will do though is I will post my a scaffold project that has our setup, and so you guys can look at it and modify it as you want. So that's it. All right.
Awesome. Thank you, Richard.
Thank you.
I didn't plan to do this, but I'm going to do this real quick. I'm going to tear that off. That was unplanned. No, but I want to do a little slide real quick. So I wanted to talk about giving a talk at Full Stack, which is one of my favorite topics. I could give a whole talk about giving a talk about full stacks. Okay, so we are looking for people to give talks at Full Stack. If you are interested, then this is where you go, fullstacktalks.com/submit-a-talk. That'll just put you to a form where you could submit a talk idea. We are looking for all sorts of talks. So if you are at all interested, then we would love to hear your talk idea. Also, if you just want to give general feedback, this is a place to do that as well. So you may be thinking, well, what could I talk about? And I guarantee you something's going to come to your mind as I'm going through this list, and we want to hear about it. Okay, so here's some ideas. Your favorite programming language. It could be something like TypeScript or Elixir or Ruby or JavaScript or some Rust, something very obscure. It could be some popular or obscure library that you enjoy using. It could be a collection of Today I Learned. We try to do about 20 minutes a talk, and that's not that many Today I Learns. That's like 10 of them, you know? That's 2 minutes. It's hard to fit something into 2 minutes. So if you think that you can't get up here and talk for 20 minutes about some things that you learned over the course of 6 months, then you were wrong. In fact, this is kind of in the realm of that, but like one of my favorite talks, other than tonight's speakers, of course, was Katie's back there. She gave a talk about some libraries in Ruby that were just, you know, they were in the standard library, but you're like, why would you ever need these methods or classes or modules? And she just kind of went through those. That was fun. I enjoyed that. It could be a side project you're working on. If you've got something going on, you think it's pretty cool, you want to show it off, this is the place to do it. We want to see it. It could be something about computing that brings you joy. There's a whole conference called Bang Bang Con that I really like. And all they do is have topics about stuff that brings you joy about computing. And it's really fun to hear those talks because people get excited about the things that bring them joy and they want to share that joy with other people. So if there's something about computing that gives you joy and you can present it, then we want to hear it. It could be a helpful tool that you found that you want to share. Mark's fits in that category. It could be something that you've wanted to learn yourself. I gave a talk at a conference a couple weeks ago that Richard was at. It was cool seeing him there. So at the speakers dinner, we were kind of joking around that a lot of us do what we call talk-driven development. We have something that we want to learn, so we submit a talk idea at these conferences, and then we get accepted, and we're like, oh, crap, now I got to learn it. And so then we go and learn the thing, but we're better for it. And so if there's something you've always wondered, I wonder if I could do this, or I wonder what it'd be like to write something in this language, or what if I could create this thing, then submit the talk, we'll say yes, and then you have 2 months, let's say, to figure out how to do it, and that'll get you in the right path, and you'll be so glad you did it, I promise. Also, I want to mention, if you have never given a talk before, we especially want you. We are interested in helping you guys speak. If you're interested in that, we can train you. We'd love to look through your slides. We'd love to go over like an outline of what you want to talk about. Help you mold your talk in the right direction. Try to keep it long or short, whichever way you need to go. Some talks are too long and you shorten them. Some talks are too short and you need to lengthen them. But anyway, we're here to help you do that as well. We have some seasoned speakers on staff. We've got some speaker like Richard's now. He's spoken twice at Full Stack, so he can help you out. So we do have some kind of mentorship that we can provide if you are interested and you just aren't sure that you've got the skills to do it. You do. You do. Okay, that's it. That's all I would. Remember, fullstacktalks.com/submit-a-talk. You've got one we want to hear, I promise.
Thanks, Gio. Oh my goodness. Okay, I genuinely love the idea of what brings you joy. So, question time with Dana. I usually, in my one-on-ones with my team, I say this. It's like half ideas with Dana because I'm a verbal processor, and so I say half an idea and then I change the subject on myself. It's real cute. But today I'm going to stay on task. I'm going to ask you, what is something about your job that brings you joy? I'm going to need like 3 people to give me an answer. So please don't make me call on you. Please give me volunteers because it is my favorite thing to embarrass people, and I've got a lot of people here that I could just. Anyway, things in your job that bring you joy in development or whatever it is that you do. Oh, I don't see any hands. Rick, I'm coming to you, my friend. Do it from the beach. I love that. What is it about the beach and development that you love? You're a developer, yeah? I feel like we've had that talk before. Oh, God, I'm such a bad rememberer. Okay, I'm just going to pretend like that's not true. What do you do for work, my friend? Cybersecurity, and you do that from the beach. Okay, I'm just going to go on a little tangent right now, and when I think of cybersecurity, I for sure am not imagining somebody on the beach, so kudos to you. Okay, somebody else, what brings you joy in your job? Robert? Thank you. Okay. Yes. 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 I read this quote when I was in my mid-20s. It said, change comes when you learn enough you want to or you hurt enough you have to. And when I read that, I was determined to grow when I learned enough I could and I wanted to. So I love that idea. But anyway, let's always be forever students, right? Okay, I need one more volunteer. Oh, I love that. Thank you, Richard. Okay, so lots of joy. You guys are just so happy in here, and I love it so much. Okay, so one of the other things that we do at Full Stack before I get off the stage and release you to more beer and snacks, we're going to talk about hiring and looking for jobs. So if your company is hiring for somebody, we want to hear about that. And if you are a person that is looking for a job, we want to hear about that. I know there's one person in here, but I don't want to embarrass that person, so... Is there anybody here that wants to share, possibly volunteer? Point fingers. I'm coming this way. Who am I pointing? This way. Rick? Okay. You? Oh, hey, Brandon. I remember your name.
Oh, and I have a mic too? Oh, wow. Jeez.
What are you hiring for?
What am I hiring for? Oh, well, I'm looking for male models, hand models specifically, if you know of anyone. Oh, you went? All right. Q starts right over here, so... wait, was this seriously people looking for work or for people hiring? I missed it. Missed? Okay, both. Well, technically I'm looking for work, but the countdown clock's coming because I got a job up in LA, but I want to stay here. So I got about 2 weeks if I can find something down here, front end. So I guess I should tell you what I do. I'm a full stack modern developer. If you got specifically front end, I'm looking for something front end, but I can do full stack too. So that's what I'm looking for.
Thank you, sir. Anyone else want to share what they might be looking for in a job? Okay, hey!
I'm also I live in San Diego, so I don't need a job in 2 weeks. Although I can start in one day. I'm looking front end full stack, but full stack would be like I know PHP, MySQL. So I'm okay any temporary job, anything, you know. So if you, I can show my portfolios.
Thank you, ma'am. Anybody else before I go so far away? Guys, these shoes are not comfortable to hop around in. I'm going to be honest. It's the wrong shoe for this event. Okay. All right. So there's more drinks in the fridge and there are snacks in the kitchen. Please, please, please hang out with one another. Build community with us. And thank you guys so much for coming tonight.